right. Also, next to last warning on the homework, the 5.6 homework has a due date of Friday at 11:59 p.m. That is the only assignment that I will not accept late, because I have to have all assignments in by 11:59 p.m. this Friday, so that I have enough time to grade everything before we actually take finals the week after that. Okay? So 5.6 homework is due on Friday, along with everything else that you may or may not have turned in up to this point. 11:59 p.m. All right. Let's go ahead and look at your 5.6 guided notes. We're going to be solving exponential and logarithmic equations, which we've been doing in 5.4 and 5.5 and previously. So a lot of this is going to be review, with a couple harder type problems thrown in that we haven't had a chance to look at yet. This first one up here where it says simplify, how will this simplify? X. My exponential and my log, the bases match. So they cancel. When I have an exponential raised to a logarithmic base, and those bases are the same, they will cancel out the same way as if I multiply by 5 and divide by 5, where I add 7 and then subtract 7. They're inverse operations of each other, and so they will cancel out when those bases match. How will the middle one simplify? Let's be 4. And the one on the far side, far right, how will that one simplify? 27x. Exponential problems. What can I use to help me solve number 1? What idea, what property, what skill, what do you say? We can drop our bases. Why? Same on both sides. So those in effect are going to cancel each other out. I have x minus 1 equals 2x minus 2. I'm going to subtract x from both sides. Add 2 to both sides. And I end up with what? 1 equals x. Absolutely correct. Do I need to check that answer? Do I need to determine whether or not it could potentially be extraneous? What's our domain for all exponential functions? What are the valid values for x? What did you say? Not 0 to infinity for my exponential, that'd be my logs. What about my exponential? What's my domain? All real numbers. X is allowed to be anything with our exponentials. I can have any type of number as an exponent. I can't get any type of output back. That's what causes that horizontal asymptote that we see in the graph. But I can use anything I want to as a value for x. If I'm allowed to use anything I want to as an exponent, if anything is okay for x, do I need to check my exponentially printed answers? There's no way that they could be extraneous. There's nothing that could be outside of the domain, because the domain is all over the place. Right. What about number 2? How would you approach number 2? Change the 16. We're going to rewrite that as what? 4 to the second power, 4 squared. And then that's all going to be taken to the power of x plus 9 equals 4 to the power of x minus 2. how do I deal with this here? Multiply, we're gonna distribute that 2. So I would have 2x plus 18 equals x minus 2. Once my bases match, those are gonna cancel each other out. So that I can subtract x from both sides. Subtract 18 from both sides. And I get what? X equals -1. On number 3, can I rewrite 1/8 as a power of 4? No. So how could I approach this problem if I can't write 1/8 as a power of 4? I can write it as a power of 2. 1/8 would be 2 to what power? -3. So 2 to the -3. So then what do I do with the 4? 2 to the second power, 2 squared. All to the power of 6x plus 2. I want to pause here for just a moment because I saw something happen on the last quiz, and I just want to take a moment to address it. We know that 1/8 is the same as 2 to the -3. What I had happen on the last quiz is when we had a fraction and we were trying to rewrite it as a whole number base, some people were putting that up as a fractional power. If you have a fraction as your argument, then it is a negative power. You have a fraction as your argument, then it is a negative power. So be very, very careful there. If it is a negative fraction, that would be a fractional argument with a root on the bottom. If you had a negative, like if this was -1/3, let me write out what this would look like. 2 to the -1/3 would be 1 over the cubed root of 2. Negative power is going to turn it into a fraction. And then a fractional power would make it a root. Does that make sense? Okay. So there's our little side note. So we would 1/8, the -1/3 power would be 2. So it's 2 to the -3. So if we did the cubed root of this, give me a minute to look at that. I think I hear what you're saying, but until I write it down, it's like my brain's getting lost in the numbers too much in my head without it being on paper. We're going to distribute our 2 here. So 2 to the -3 equals 2 to the 12x plus 4. The bases match. So I can cancel those out. I'm going to have -3 equals 12x plus 4. Where to from here? Subtract 4 from both sides. So -7 equals 12x. And what? Divide both sides by 12. And so my final answer here would be x is negative 7/12. How would you approach number 4? What can I do here? What am I looking for? Yes. When what we're looking for is the exponent, that's what logs do. That's the whole purpose for having logs. Logs find exponents, logs isolate exponents. So if the thing I'm looking for is an exponent, I'm going to rewrite this as a log. Yes, I would go with natural log. You want to find an exponent. Rewrite it as a log. So natural log, because we have a base of e of 6 equals x. If my problem asked for an exact solution, I would write this down right here. This is what I would type in if it said type in the exact answer. If it asked for the approximate answer, I would grab my calculator then, and I would type in natural log of 6. And when you type in natural log of 6, you get what? 1.792. Number 5. What can I do for number 5? Can I use the same trick that I just did here right out of the gate? Yes. First thing you're gonna have to do is isolate your exponential. We want to isolate x as much as possible, and then we will rewrite it as a log. So what would I do first as I'm trying to isolate this? Plus 5 on both sides. So 2 times e to the negative 3x equals 8. And then what? Divide both sides by 2. So e to the negative 3x equals 4. What can I do with that now? Yes, now we're going to rewrite this as a natural log. So the natural log of 4 equals negative 3x. And we can divide both sides by negative 3. So exact solution, natural log of 4 divided by negative 3. There are quite a few problems on the 5.6 homework that ask for the exact solution. And so that's what I would type in anywhere it is asking for the exact solution. A lot of times it then asks for the approximate solution after that. So then I would type it into my calculator. And what do you get? Let's go ahead and take it out to 3 decimal places. Yes, negative 0.462 for your approximate. All right, walk me through number 6. What are we gonna do? Yes, first we're gonna subtract that 5 from both sides, so I have 10. So the 3x minus 1 equals 25. And then natural log again, right? Common log. Why common log? Because the base is 10. So common log of 25 is equal to 3x minus 1. Why did I put the 25 inside parentheses? I don't want to confuse it with a base. I don't want to confuse it with a log. I also need to remember that logs are operations. When I'm thinking order of operation, what's order of operation? And before I can do any adding or subtracting to things, I would have to do any multiplication or division. Before any multiplication or division, and addition or subtraction, I would have to take care of exponents and logs. Exponents and logs happen in the same step. Addition and subtraction are inverses of each other, so they happen at the same time. Multiplication and division are inverses of each other, so they happen at the same time. The same thing is true about exponentials and logarithms. They're going to happen in the same step together. So I have to do that before I can combine it with any addition. So I'm adding 1 to both sides, but that will not become common log of 26. So I have log of 25 inside parentheses, and then plus 1 after that. It is not going to turn into log of 26. Because I have to do this operation first before I'm allowed to do any other operations to it. So when we're talking about order of operations, what you're trying to accomplish determines whether you go from top to bottom or from bottom to top. When I'm trying to isolate something, so like here I'm trying to isolate x, I go from the bottom to the top, so I undo the subtraction here. But when I move it to the other side and I add it over here, that I'm trying to evaluate. So now I'm going top down. Does that make sense? Yeah. So isolating, I go from bottom up. If I'm actually putting stuff into my calculator or I'm actually trying to combine my terms, I'm going from the top down. Some calculators know parts of that. If you type it in the way it looks on my screen right now, where you do log 25, yeah, use n over d. Put the 25 inside parentheses, and then the plus 1 outside of the parentheses, and then you put the 3 in the denominator. These yellow calculators will spit back the right answer. How you enter things in the calculator, though, is really important, along with which calculator you're using. I'm sure you guys have noticed cell phone calculators like complete things as you type them in. So you have to put them in the order of operations, and you're using a cell phone calculator. Otherwise, it will do it in the wrong order. It's trying to give it a whole instruction, unless you need to do it in parentheses. What do you get when you type this one in? 0.799. Absolutely correct. It depends on what the directions say. If the directions say to round to like 3 decimal places, I would leave it like this. If it's said to round to 2 decimal places, then I would round 0.80. So it all depends on the rounding direction. I had a really good question earlier today in first period as far as how far do we round out to? 2 is always required, 2 decimal places is always required, 3 is usually preferred. 3 decimal places gives me the opportunity to simply do the right answer. You just round it differently than me, or did you not put it into your calculus correct? So if there are no directions about rounding, 3 is the safest. We really don't ever have to go past 3. All right, let's knock out these last 3 problems. Number 7 looks weird compared to the other ones that I've done. Because with all the others, I either have an exponential on both sides, and I can deal with that, or I have a constant on one side and an exponential only on the other. What do I have going on here? Do I have any constants? Yes. Do I have any exponential? How many? Can I combine them together? No. How many terms do we have? 3 terms. This is starting to remind me of something. I've got 3 terms and it's set equal to 0. Looks like I'm gonna want to try to factor this. This is called a quadratic type equation. Because they're being added. If they were being multiplied, you could. If I have the same base that's being multiplied, then I can add the exponents. But since it's addition in between my bases, I can't. So this is a quadratic type equation. We're going to use substitution here. You guys remember using U substitution on quadratic type things that look almost like quadratic but weren't? Yeah. Okay. So I'm going to let U equal e to the x. So I'm looking at my middle term first here. How will I rewrite this middle term once I've done my U substitution? What will it look like? 2U. So it's going to be plus 2U. That minus 15 is still the same. It's equal to 0. Now let's go look at this first term. What will the first term look like? U squared, yes. Let's look at this right here. If I undo things that we've been doing, this would be e to the x squared. What can we do with these 2 pieces right here? These 2 pieces, we can multiply them together, so that'd be the same as 2x. So this is going to be u squared here. Once I write it down like this, do we know how to factor that? Yes. What multiplies to negative 15 and adds to 2? 5, positive 5, and u minus 3. So what are my values for u then? 3 and negative 5. Were we asked to find u to go? Yes, sir. Okay. We weren't asked to find u. We were asked to find what? X. So now I'm going to have to go and undo this u substitution here. So everywhere I see a u here, I'm going to replace it with e to the x. So e to the x equals negative 5. E to the x equals 3. How do I solve those now? Didn't we do a problem that looked kind of like this? I want to say like problem number 4 looked like that. How did we solve problem number 4? Yeah, we rewrote it as a natural log. Okay, so I'm going to do that. Natural log of -5 equals x. Natural log of 3 equals x. So what am I going to do? Ooh, why is that? Why is -5 giving us a domain error? What is the domain for all of our logs? Has to be positive. So no negative arguments. This one is not going to give me a solution. But I can do natural log of 3, right? This would be my exact solution right here. And to get my approximate, I'm going to pop that into the calculator and get what? 1.098 or 99 if you round up. All right. Number 8, use substitution here? Nope. How would you start number 8? I would add 5 to both sides. I like one here. All right, so I have 4 to the power of 2x plus 3 equals 14. Can I rewrite 14 as a base to a power? No, 14 is 2 times 7. There's absolutely no way. It's not a power of 7. It's not a power of 2. I cannot rewrite that. So how do I approach this problem? What do I want to find? I'm looking for an exponent, right? So what do I do if I'm looking for an exponent? Rewrite it as a log. What would the base of my log be? 4. Log base 4 of 14 equals 2x plus 3. Can I put log base 4 of 14 into my calculator? No. So what can I do to this right here so that I can evaluate it in my calculator? Change of base. Common log or natural log? We get to pick, it doesn't matter. We just have to pick one of the ones that's on the calculator, common or natural. Common sounds good. So common log of what? 14, original argument first, over common log of what? 4. Change of base. Yes. You are lucky. Some calculators do, Casios in particular usually do, Texas Instruments do not. If you have a Casio calculator, it already changes the base for you so that you can evaluate log 4 of 14. You do not have to change the base. Okay, I have this. Yeah, Texas Instrument calculators do not allow you to change base. Casios do. All right. All right. What do I do from here? What do I do from here?
Oh, you said you like put that in and you like subtract it.
Yep, so if it's asking you for an exact solution though, you would not want to put that into your calculator yet. So I would have log of 14 over log of 4 minus 3 equals 2x. And then what to isolate x? Divide that entire horrible expression by 2. So x equals log of 14 over log of 4 minus 3 divided by 2. There's my exact solution. X is approximately what do we get? Negative 0.548 is correct for the approximate solutions. So somebody asked me a really good question in first period as far as like for exact, because again, the homework does ask you to type in exact solution for several of the problems. How would you type something like that into Canvas? I would start off up on the top. I would open up a double set of parentheses. So parenthesis, parenthesis. Log of 14 divided by log of 4, and I would close my first set of parentheses. Then I open it again. Then minus 3, then I would close the second set divided by 2. I can write it down for you, absolutely. In a moment. Let's do the last problem here on this side. We're going to hold off and not start the back side until tomorrow, because the back side is all solving logarithmic equations. What are we looking for on number 9? What do I want to find? I'll help you get it. What are we looking for on number 9? X. Where is x? In the exponents. On which side? Both sides. Okay. So I would say to do what? We want to get rid of the bases. What operation do we have that will get rid of exponential bases for us? What have we been doing? What do we do here? We took a log. We rewrote it as a log. Well, if I'm going to rewrite this as a log, do I use a base of 2 or a base of 3? Base of 10. Let's take a log of both sides. I can choose any base that I want to. If you do it to one side, you have to do it to the other side. Exact same operation. Take a log, both sides. We can go with common log, or we can also choose what? Natural log. Since on the last one, when we did change a base, we did common log. Why don't we do natural log on this one? It does not matter. You get to choose which one you want. I'm going to do natural log of 2 to the x plus 7 equals the natural log of 3 to the 2x. And now I can take advantage of a property that is specific to logs that I couldn't do before. Our property. I can take this 2x and drop it down in front. I can take the x plus 7 and drop it down in front. X plus 7 has to go inside parentheses because that entire thing is being multiplied to the natural log of 2. Making sure to pop my arguments inside parentheses so I don't cause myself any grief. What are we looking for again? Looking for X. Where is X? On both sides. Over here, I'm gonna distribute, yes. Use the distributive property, but I have X natural log of 2 plus 7 natural log of 2 equals 2x natural log of 3. How can I get my x's to the same side now? Adding and subtracting, let's subtract x natural log of 2 from both sides. Are my arguments the same on the right-hand side? Then I cannot add and subtract those x's in the front. It's just going to stay a long expression. So I have 2x natural log of 3 minus x natural log of 2. Where is x? On the right side, it's right here. And it's right here. What can I do so that I can try to start isolating that? Yes, I'm gonna pull it out as a GCF. Pull x out to the front. That would leave me with 2 natural log of 3 minus natural log of 2. Over here on the left-hand side, that's 7 natural log of 2 didn't change. How do I get x all by itself again? Divide. I'm going to divide by 2 natural log of 3 minus natural log of 2. That solution x equals 7 natural log of 2 over 2 natural log of 3 minus natural log of 2. What's our approximate solution to this one? 3.226.